So on the second day of hyperbolas, we're going to be graphing hyperbolas. You recognize the standard form of a hyperbola. Looks very much like the standard form of an ellipse. The difference is simply there's a minus instead of a plus here. If there's a plus, you get an ellipse. If there's a plus. If there's a minus, you get a hyperbola. All right, so when it's a plus, you get an ellipse. When it's a minus, you get a hyperbola. Graphs look different, right? So the idea of a hyperbola, what we need to graph for a hyperbola, is the center, two vertices, two foci, and two asymptotes. And sometimes when you see book problems, I've been making up my own worksheets, but when you get book problems, they'll say write the equations of the asymptotes. The only thing you really need to know about the asymptotes is the slopes in order for graphing purposes. So I don't really worry too much about the equations of the asymptotes. But first thing you always want to do for graphing any conic section is get standard form there. So we already have standard form. Recognition of up, down, left, right comes from what's positive. So once you have standard form created, you have a y squared and x squared and a equals 1. Wherever the minus sign is, the plus sign is on the other one. So the plus sign is on y, the minus sign is on x. Since the plus sign is on y, it's going to be an up-down hyperbola. And again, it's up-down because the y object is positive. Just like the y-axis goes up and down, if y is positive, the hyperbola goes up and down. That's got a minus in front of us, x is negative, that has nothing in front of us, so it's understood to be a positive. All right? So positives are always understood unless you have some other symbol to recognize. So there's always, with hyperbolas, one positive, one's negative every time. All right, so again, it has to be in good standard form though. Something squared minus something squared equals 1. Both squared things over some number. All right. Next, my center is simply going to be h comma k. This is the same h and k we've had for all of the conic sections. H is always with x, k is always with y, and the signs are always the wrong signs in the standard form. So 1 is with x, it's negative, so h is positive 1. 2 is with y, it's negative, so k is positive 2. H is with x, k is with y, change the signs that you see. B squared is always under y, and a squared is always under x. So be careful, it's not always a squared and b squared. Find x, a squared's under x, find y, b squared's under y. So b squared is always living under y, a squared is always living under x. That makes b equal to the square root of 4, which is 2. A equals the square root of 5, which is about 2.24. I would get decimal approximations for everything. C squared equals a squared plus b squared. Doesn't matter what's positive, what's negative in hyperbola. C squared is always a squared plus b squared. So you simply add those two numbers together. That's c squared. So in this case, c squared is equal to 9, which means c is equal to 3. And the final thing I need to identify before I start putting things to graph is I need to get the slopes of the asymptotes. The slopes of asymptotes are always plus or minus b over a. In this case, that's going to be plus or minus 2 over 2.24. Now typically, I wouldn't have a fraction that has decimals in it. But for the sake of graphing, I can approximate how far 2.24 is. I want to use rise over run to create lines.
And it's always what one is bigger?
It's always b over a. Not bigger over smaller, it's b over a. Whatever b is, whatever a is, put b on top, put a on the bottom. No matter what's positive, it doesn't matter. B over a is always the slopes of asymptotes. All right? So that's the information I need to gather in order to graph the hyperbola. Once I've gathered that information, here's how I use it. First thing I do is I graph the center. Everything comes off the center, so always graph the center first. So 1, 2 is right here. That's the first thing I do. The second thing I do, since it is an up-down hyperbola, I'm going to focus on B and C. I'm going to go up and down those amounts to create vertices in foci. There's going to be a vertex up and down. There's going to be a focus up and down. So 2 vertices, 2 foci off the center. So if I go 2 up, I get a vertex. I go 2 down, I get a vertex. Oops. If I go 3 up, I get a focus. If I go 3 down, I get a focus from the center. So here's my center. 1, 2 up, 1, 2, 3 up. 1, 2 down, 1, 2, 3 down. So that's second. The third thing I do is I create the asymptotes. I'm using my slope of positive 2 over 2.24 and negative 2 over 2.24 from my center to create lines. So the asymptotes always go through the center. We just need a second point for each one. So if I go up to right 2.24 and go down to right 2.24 off the center, one slant asymptote goes that way, one slant asymptote goes that way. So again, the center itself is on the slant asymptote as well. So I would simply create a dashed line to represent that. And I usually use a straight edge when I'm drawing slant asymptotes. So if you're like graphing on your paper, you grab a ruler and get a nice straight line there. And then you do one the other direction as well, coming through this point. Like so. Once the slant asymptotes are there, that just is the boundary for your graph. So the last step, the fourth step, is to actually create the picture. So I'm going to put forth here is make the picture. And that just means that I'm going to go through the vertex. I'm going to stay near the asymptote, go through the vertex, go near the asymptote. So I'm just going to create what looks like a parabola almost. I'm going to stay inside those asymptote lines. Those asymptotes represent like a barrier the graph's not allowed to cross. So there's going to be one part above and there's going to be one part below. Again, the vertex is here, so I'm going to stay near my asymptote. I'm going to go up through the vertex. Go up through the vertex of the curve and come back down towards the asymptote again. But again, your task as far as the problem is concerned is to glean all this information from the problem that's written in standard form to establish what it's supposed to look like, put everything where it belongs, and then make the picture. All right, and that's how you graph this. I would expect to see this type of work on your paper. Notice A was only used for the slopes of asymptotes because we went up and down. If this had been opposite, if it x minus 1 squared was positive and y minus 2 squared was negative, it would have gone left and right. Everything would have been the same. These would be the same. This would be the same. I would have gone 2.24 right and left and 3 right and left, and my hyperbola would be here and here instead of there and there. So either A or B is necessary for the vertices. A squared is necessary to find C, and A is necessary to find the slopes of asymptotes. So both numbers are necessary, but only one is being actually graphed. All right, let's keep that in mind.